Okay, I think we can start now. So, guys, we have finished a data transfer instruction. Okay, and tomorrow we are gonna have a lab on this section. Also, we are gonna have a quiz. So the quiz is gonna look like something like. I just want to make sure you understand the instructions. So I'm gonna give you. Let me see. It's gonna be like the examples you have here. Okay, so I'm gonna give you one. Sorry. Addition. Okay, let me go back. Yeah. So for example, here I'm gonna give you like an instruction like this one: exchange A, B, and then I'm gonna ask you after we execute this instruction, what are the values of A and B? Okay. I just want to make sure you understand what this instruction is doing. Okay. Gonna be something like that. Maybe I'm gonna give you also something like that. Move byte 1000 and 2000, and then I'm gonna ask you what is the content of memory location 2000 after you execute this instruction. Okay, so this will be the quiz tomorrow. Also, we're gonna have a lab on these instructions. Also, there is also the second part of tomorrow's lab is actually about addition and subtraction as well. So I already explained addition and subtraction. I actually finished all the arithmetic instructions we have, except the multiplication and division, and that's what I'm gonna do right now. Okay. So tomorrow's quiz is gonna only cover the data transfer instruction. Okay, but next week is gonna be about arithmetic instruction. Okay, so. Yeah, here guys, for arithmetic instruction, as I told you last time, we have addition, subtraction. I already explained to them. I explained all the instruction we have: increment, decrement, complement, negate, clear, and set some flags. Also, you can clear some registers. Okay, I explained all of that. Only what is left in this section is multiplication and division, and that's what I'm gonna do right now. Okay. So let's see what instruction we have for multiplication and division. Okay, so for multiplication, guys, we have only 3 instructions for multiplication. The first instruction here is called MUL or mul, okay? And we have a second instruction, EMUL, and then we have EMUL as you see here. So we have only 3 instructions, as you see here, okay? All these instructions are inherent, so you don't need to write any operands in this instruction. So how they work? Mul, you just write mul. So once you write here this instruction automatically is gonna multiply register A by register B and store the result in register D. So this one here, you are gonna multiply a byte times a byte, A and B, and you store the result in a word. Okay. As you see right now, usually, because when you multiply 2 numbers, the result is gonna get bigger. Okay, that's why we're storing here the result in a word, not byte. Okay, so and here these multiplications are for unsigned numbers. Unsigned numbers. Okay, we have another instruction here. We call it EMUL. This one, similar to mul, it is also for unsigned numbers. So these 2 instructions are gonna do unsigned multiplication. Does it matter in multiplications if the number signed or unsigned? Yes, it matters. Okay, but it didn't matter before in data transfer instruction. This is the first time I explained some instruction and I tell you this instruction for signed or unsigned. This is the first time, right? When I explain data transfer instruction, I didn't say this for signed or unsigned because it doesn't matter. You just copy bits. You got what I'm saying? Even for addition and subtraction, it doesn't matter because addition, it's bit by bit addition. You got what I'm saying? So also doesn't matter if signed or not signed. So we don't have 2 types of addition, if it is signed or unsigned. No, you just bit by bit. 1 + 1 is 0 and so on. This can work for both cases. That's why I didn't teach addition for unsigned, addition for signed, but here multiplication, it matters. I'm going to tell you why. Okay, so I think I have very good example here. So let's see this example to better understand why it matters. Look here, guys. If you have this number 1111, okay, I always use this number, right? And I want to multiply this number by this number, okay? So if you consider these numbers unsigned, that means you want to multiply 255, which is this one, times 3. And the result should be 700 something, okay? 700 something. Is that right? However, if you consider the number are signed, so this one is actually -1, okay? -1. So I'm going to multiply -1 by 3, and the result should be -3. The bits of -3 are not the same like 700, okay? So they are not the same. That is why we should have two separate instructions, one for signed and one for unsigned, okay? And when you are the programmer, when you write your program, you need to decide what numbers are signed, what numbers are unsigned, and then you have to use the correct instruction, right? So if your numbers are unsigned, so you have to do unsigned multiplication. If your number is signed, you have to do signed multiplication. Okay, guys, any questions? Okay, so let's see. So for unsigned, we have, for multiplication, we have only 3 instructions. That's all what we have, only 3, okay? 2 of them for unsigned, okay, and this one can multiply, or this one multiplies byte by a byte and to store the result in a word, okay? So A times B and store in D, always, all the time A and B, right? So you cannot change it. Always, all the time it's A times B and then the result in D. And then the second one is E-mul. So this one multiplies a word by a word and to store the result in double word, okay? So the result is 32 bits. That's what I mean by double word, 32 bits, okay? So the first word in register D, so this one always multiplies register D by register Y, and the result is going to store it in D and Y as one number, okay? D here is the least significant word, Y is the most significant word. So it's like you concatenate D and Y to get one number, 32 bits. Is that okay, guys? So again, here you don't select what registers, because you remember all this multiplication are done by the hardware. So the hardware circuit is connecting the multiplier to D and Y, and the result is stored here. Okay, guys. The last one we have E-mul S. So look here, it's the same exactly the same thing, but you have to put letter S here, and this S actually it means it's signed. So this one is exactly similar to this one. It multiplies a word by a word, D by Y, and to store the result in a double word. But the only difference between these two instructions, this one is used for unsigned numbers, this one is used for signed numbers. Is that clear, guys? Any questions? Okay, great. So now I want to talk about division instructions. For division instructions, we have here, we have 2 instructions, okay? This instruction can divide 16-bit by 16-bit numbers, so 16-bit number or word by word, okay? And then here when you do division, guys, this is different from your calculator. In your calculator, when you do division, you are going to get something 3.75, something like that. Here, you are not going to get something like that. You are going to get quotient and remainder. And I'm going to explain what I mean by quotient and remainder. Okay, so here, once you do division, you are going to get 2 things. You are going to get what is the quotient and what is the remainder. Okay, and then you can use them to do whatever you want to do. Okay, so here, so let's see first, before I continue here, let's see what you mean by quotient and remainder. Okay, for example, here, if I divide 10 by 3, as you see here, okay, so you are going to get, this is what you are going to get, quotient and remainder. So the quotient is in this case is 3 and the remainder is 1. So what this means, I'm going to tell you what it means. It means, so we have here 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we have 10 here, okay? So when you divide by 3, actually it means I'm going to make groups of 3. So this is one group of 3, second group of 3, so how many groups of 3? This is the quotient. So the quotient is going to tell you how many groups of 3 you have. That's the quotient. Remainder, so what is the remainder? Okay, so this one is not enough to make a group, just one. To make a group, they have to be 3. This is the remainder. Is that clear, guys? So this is the quotient. That is why this remainder always, all the time, this remainder should be less than this number. It cannot be equal to 3 or greater than 3. It cannot. Make sense, right? Because if it is 3, it would make a group, and I would add it here. Is that okay? So that's why always the remainder has to be less than this number. Okay, guys? This is the meaning of quotient and remainder, and that's what we get when we do division. Okay. So to do division here, we have 2 sets of instructions. We have some instructions that divides 16-bit by 16-bit, and then they give the quotient in 16-bit and the remainder in 16-bit. This is the first one we have. Okay, and here, this instruction here, we have 2 of them. One is called IDIF, and another one is called IDIF-S, as you see here. So IDIF and IDIF-S. So these 2 instructions are actually divide. They are the same. They are the same. The only difference between them, because this one has a letter, letter S. So this one means this is for sign, this is for unsigned. Okay, but everything else they are the same. Okay, so these 2 instructions actually divide 16-bit word by word and store the quotient in a word and the remainder in a word. Okay, so automatically this instruction is going to divide register G by register X, and the quotient is going to be stored in X, remainder is going to be stored in G. So if you want to divide 2 numbers, guys, you have to put the first number in G, you have to put the second number in X, and then you have to do division. After that, you are going to get the quotient in X, and then you are going to get the remainder in G. Is that clear, guys? Any questions? Yes, sure. Sorry. Yeah. Yeah, so I'm not going to teach you this one. This is for if you want to, if you need like doing like division, use if your numbers are fraction, right? So I don't think we are going to need it. That's why, yes, we have one more instruction, but I'm not going to teach it because our focus here, these numbers, 16-bit number and 16-bit number, are not fractional. There is no fraction. Okay, so I don't think we need it. That's why I'm not going to teach it. Okay, but it is used if these numbers here, the numbers you put here, are fractions. They have fraction. They are not integer numbers. Okay. So also here we have another instructions here, 32-bit, and this instruction divides 32 bits by 16-bit, as you see here. And the quotient, so number 32-bit number, this is the number, and 16-bit number. Okay, and the quotient is going to be stored in 16-bit, and the remainder is also stored in 16-bit. So here, this is the same, like this one, 16-bit, 16-bit. The only difference between these 2 instructions is that here you divide 16-bit by 16-bit, but here you divide 32-bit by 16-bit, okay? So for this one, we have 2 instructions, EDIF, and we have EDIF-S, as you see here. So again, this one for unsigned, and the one that has S here, this is for signed. So here you divide 32 bits by 16 bits. So where are the 32 bits? The 32 bits are actually Y and D, as you see here. So Y and D. D is 16, Y is 16. So D actually, register D here is the least significant word. Again, this is 32 bits. So it should be 2 words, right? So this is the most significant. D is the least significant word. Y is the least, the most significant word is Y. And so this is, if you concatenate G and Y together, I'm going to have like one number, 32-bit number, one number. Okay? And then you are going to divide it by X. And then the quotient is going to store in Y, remainder is going to store in D. So if you compare this one to this one, so here, this one is D and D is also here, X is here, X is here. Quotient, the remainder is going to go to D, also remainder is going to go to D. But the difference here, the quotient is going to go to X, here the quotient is going to go to Y. Also here you divide 16-bit, here you divide 32 bits, okay? If I go back here, you can see here the result of this multiplication operation is in Y and D as well. Look how they are matched. Look here. Here, that you can do multiplication and the result is going to go to y and g. And then if you want to do division, you can take this number in y and g, you can divide it here. You got how they are mentioned. So the output of multiplication, you can use it in division here. So for example, if you have operation, you want to multiply, and after you multiply, you have 32-bit number, and then you want to divide it, and so is that okay, guys? So let me summarize what I said. That's all what we have. So again, all what we have, guys, you can multiply, summarize what I said, byte by byte, and store the result in word, or you can multiply word by word, store the result in double word. And this is unsigned, unsigned. This one is signed. Here, you can divide 16-bit by 16-bit, okay? And then you can store the quotient in 16-bit, the remainder in 16-bit. Here you can divide 32 bits by 16-bit, quotient 16-bit, remainder 16-bit, okay? And again, we have some instructions here for sign and sign, unsigned, some instruction for sign, okay? So you can see there is one difference between multiplication and division. In multiplication, I can multiply byte by byte, store the result in a word, but we don't have here, you cannot divide byte by byte. We don't have an instruction to divide by byte by byte. It should be at least 16-bit by 16-bit. Okay, guys? So someone can ask me, okay, but what if my numbers are byte? So I want to divide by byte by byte, right? We don't have an instruction to do that. What I can do? Very simple, very simple. So all what you have to do, you remember last time when I explained the idea of extension. So you have to extend. So I think I wrote it here somewhere. Yes. So here, if I want to divide byte by byte, guys, I don't have this instruction. So the way you have to do it, you have to extend this byte to a word, signed or unsigned. It depends on your number. I explained before how can you do signed and unsigned extension. Okay, so you have to extend this byte to a word, you have to extend this byte to a word, and then you divide, you should divide word by word. Okay, same thing if I go here, same thing here, guys. I can multiply byte by byte unsigned, but I don't have an instruction to multiply byte by byte signed. So we don't have this one. For signed, you can only multiply word by word. Okay, same thing. What if your numbers are bytes? I want to multiply byte by byte, and they are signed. What can I do? Simple. Just extend this one to a word, store it in G, extend this one to a word, or the second number, extend it to a word, store it in Y, okay? And then multiply G by Y, then you can get the result here. Any question, guys? Okay. Any questions? So let me ask you a question here by common sense. I want to hide the answer. Just give me 1 second. Look here, guys. I explained to you before the idea of overflow. Overflow can happen. For example, let me ask you a question. Can overflow happen here? Yes, it can happen, because maybe when I multiply byte by a byte, maybe I need to store it in bigger than a word, okay? Maybe it can happen, right? Overflow also can happen here, right? Because if you look, for example, here, what is the maximum value I can put it in A? 255, right? So if this one is 255, and this one is 255, and the maximum, my limit here is 65,535, this is the maximum number I can store in a word, okay? So let's see if it can happen or not. If you multiply the maximum number by the maximum number, if it is less than this number, so it cannot happen. So let's see. Let me do it. Can anybody do it? Very simple, right? So let's do the multiplication. Yeah. So here I'm gonna multiply 255 times 255, right? So the result is actually 65,025, right? That means it cannot overflow, it cannot happen here. So if I put here the maximum number 255 by 255, this is the maximum number I can get here, and this is a word, so it should be okay. But if this one is a byte, yes, overflow would happen. But here, because I stored it in a word, it shouldn't happen. Is that okay, guys? And this is unsigned, by the way. So the maximum here is 255. Very easy, right? By common sense. Is that clear? So if you put the maximum number you can get 65.25, right? Which is less than this one. So yeah, word should be okay. So overflow cannot happen here simply because I already stored the result in big space. So the space should be big enough. I think it's also the same case here because you store the result in 32-bit. Okay. Now, but multiplication, when you do multiplication, you get the number bigger, right? So overflow can happen. So, but here it's not going to happen because I'm not going to store the result in a byte. I'm going to store the result in a word. That's why it's not going to happen here. But it can happen if you don't store it in a byte because the number gets bigger, right, in multiplication. But division is different. When you divide, you make the number smaller, right? You make the number. So overflow should not happen, right? That's by common sense. So multiplication should or can make overflow if you don't store in a bigger space, but division should not. So for example, here, I'm going to divide, I have a number 16-bit, I'm going to divide it by 16-bit. The result is quotient, the quotient is 16-bit and the remainder is 16-bit, okay? So let me ask you a question. Can overflow happen here? By common sense, the answer should be no. Overflow should not happen here. Why? Because this is a 16-bit number. Now, this 16-bit number, I'm going to make it smaller, right? Because I'm going to divide this number. I'm going to make it smaller. So if this number can be stored in 16-bit, so the quotient 16-bit should be enough for the quotient. Same thing for the remainder. You got what I'm saying? So in this case, overflow cannot happen, okay? However, look at this case. Now, I have 32-bit number. I'm going to divide it by 16-bit number, the quotient in 16-bit and the remainder in 16-bit. Can overflow happen here in this case? It can happen. Why? Because I have a very big number here, 32-bit. This is a very big number, 32-bit. Maybe after I divide this number by this number, the quotient can be more than 16-bit. You got what I'm saying? Because this is 32-bit number, very big number. Is that okay? So overflow may happen here in this case, right? Because the quotient can be bigger than 16-bit. Okay. I think it's okay for the remainder. Because if you divide as we agreed, the remainder should be a number lower than this number as we agreed. So 16-bit should be okay for the remainder. So it should not happen. So 16-bit should be okay for the remainder. Okay, because if this number here can be stored, if this number can be stored in 16-bit, okay, register, and then I am sure the remainder is less than this number, okay? That means 16-bit should be okay for the remainder. But the problem can happen here because you have a 32-bit number, very big number. When you divide it by 16-bit, maybe the result is going to be bigger than 16-bit, and in this case, overflow can happen. Is that okay, guys? In the coming lab, next week lab, there is a trick. Okay, what is the trick? So in this lab, you are going to have, it's going to be about multiplication and divisions. I give you some numbers. You are going to do you are going to put some number here. I don't remember the exact numbers. It's already in the, I'm going to post in the lab. So here, you are going to put some number here. You are going to put some number here, guys. And then after you do the division, you will find that Y and D, no change happened to them. So the numbers there, no change. Okay? You are going to come to the TA. Look, this instruction is not working. Because this instruction is not working because I'm expecting some value here, but no change. This instruction does not change Y or D, right? After I do the division. Okay, guys? So you're going to go to the TA, you're going to tell the TA, look, it's not working. Okay? Actually, it's working, but what happens when there is overflow, it does not store the result anywhere. Okay? So I'm helping you, I'm telling you, in one part of the lab, I made the numbers big enough so that they can make overflow in this case. And when you run the code online, when you run the code on Code Warrior, you will find that Y and D don't change, or the result is not stored in Y or D. Okay, that's because there is overflow. Okay, any question, guys? So overflow can happen in this case if the number here is too big, if the result of this operation it can result if this number is small, this number is too big. Yeah, for sure. When you do the division, maybe I'm gonna need more than 16 bits. Okay. I have some examples here just to show you how can we use these instructions. So, for example, I wanna multiply the word at 1000 by the word at 1002, and I want to store the result in these 4 memory locations, 4 bytes. Okay, so here I want to multiply a word by a word, and I want to store the result in double word. Double word means 32 bits, or it should be 4 bytes. Okay, and also that's not enough. I have to tell you if the numbers are signed or unsigned, right? Because that's not enough. I told you these numbers are unsigned. So now I want to multiply word by word unsigned. So if you go back to the instructions I already explained here, for multiplication, you can find this is unsigned, and this one can multiply word by word. So I have to use this one. And this one actually multiply G by Y, store the result in Y and G. So I have to write load instruction. So first of all, I have to do load instruction to store the first number here. Okay, first word here in G, and then I have to put the second number here in Y. Also, load instruction. Once I put the 2 numbers in G and Y, now I can do the multiplication. And now I have the result is here. Once I have this result, I'm gonna store it in memory locations. Is that okay, guys? Clear? So here, this instruction is multiplying 2 registers together, store the result in 2 registers. Okay, so I have to store the first number here, store the second number here, and then I'm gonna execute the instruction. Is that clear? Okay, that's what I did. Very simple. That's what I did. So here, the first word, I'm gonna load the first word to register G. I'm gonna load the second word to register Y, because this instruction is gonna multiply Y by G. Okay, so and then I'm gonna use these instructions here. This is for unsigned. After you do this multiplication, the result is going to be stored in 32-bit number Y and G. Okay. Now I want to store this 32-bit number in 4 memory locations. 4 memory locations. Okay. As we always do, we store. I told you to store it from 1100 to 1103, 4 bytes, as you see here. Always, if you have a number, the way we do it here in this microcontroller is we store the most significant byte or word first. That's why you have, so here you have 4 addresses. So we have 100, 1100. It's already written here. So this is the memory locations, right? 4 memory locations. So we store the most significant first. So I'm going to store Y first here in these 2 locations. I'm going to store G here in these 2 locations, and that's what I did. So store Y in these 2 locations, store G in this location. We always do that. If it is a word, we store the most significant byte first, and then the least significant byte. If it is a double word like this case, same thing. We store the most significant word and then the least significant word. Okay, guys, any questions? So load to put the number in G and Y, multiplication, and then I'm going to store the result. It's already in Y and G. Okay, any questions? Okay. Let's have another example about division. Very easy. Look here. Here I'm giving you a question. I'm telling you I want to divide the word at location 1020 by the word at location 1005, right? I want to divide a word by word, and then I want to store the quotient in these 2 memory locations, and I want to store the remainder in these 2 memory locations. Is that enough? No, it's not enough. You have to tell me. So I want to divide word by word store the quotient here, remainder here. It's not enough. You have to tell me if it is signed or unsigned. Is that okay? And that's here in this case, I told you it is signed. Okay. So I want to divide word by word, store the quotient here, the remainder here, and it should be signed. So if you go back and see which instruction can do that, I want to divide word by word. I want to divide word by word. Okay. So I can use this one. This instruction I have two. I have one for unsigned and we have one for signed. So because I think he's asking for signed or unsigned. I think he's asking for signed. So yeah, so I have to use this one. So the instructions that can do this kind of division is IDIFS, as you see here. Is that okay, guys? So I'm going to use this one. But remember, the way this one works, this one is going to divide register D by register X, and it's going to store the quotient in X, the remainder in D. So before I execute this instruction, I have to take the first word here. I have to put it in D, and then I have to take this word, put it in X, okay? And then I'm going to do the division. Then after you do the division, the quotient now is in X, all right? So so you have to do this one. This is using load operation. You have to do this one. This also using load operation. That's what I did here, and that's what I did here. So this is number one, this is number two. Is that okay? Load D and load X. Okay. Then I'm gonna do the division. So now I'm gonna do the division here. This is number three. Okay. Now I did the division. The quotient is stored in X. So I have to store it here, and that's what I did here. Store X. So that's what I did here. Is that okay? Same thing. The remainder is stored in register D. So I have to store it here. Okay. So that's what I did here as well. Any question, guys? Very easy, very simple. Okay. So that's the end of arithmetic operations. Any questions before I move to the next section? Okay, great. So now let's start this section. This section is the most important, I don't say difficult, but it's important section. Also, yeah, maybe, need to think about it a little bit. Hopefully, I will do my best to make it easy, but comparing to the other sections, this is the most difficult one, okay? How can you do branch and loop instructions, okay? So I'm gonna start explaining it, but again, I'm gonna repeat. This section is very important. All the time we're going to use this section. Number two, it's not straightforward like the other sections. This is, I think, I consider this section as the most difficult section here in this chapter. If it is not in the whole course, okay? So let's do it. So here I'm going to teach how can you do loop and how can you do branch instruction. By the way, before I forget, sometimes I say jump, sometimes I say branch. They are exactly, so sometimes if I see branch, or if I say branch, or if I say jump, I mean, so if I say jump or branch, I mean the same thing, okay? So don't be confused. Sometimes I see jump, sometimes I see branch, so they are the same thing. So now, in this chapter, or in this section, I'm gonna explain how can we do loop and branch instruction. But let me first explain what do you mean by loop and what do you mean by branch or jump instruction. What do you mean? I'm going to say what I mean. Usually for any programming language, it doesn't work this way all the time. We're not executing instruction by instruction all the time this way. Okay? We don't do that in any programming language. But what we do, sometimes, as you see here, sometimes we need to loop. For example, after execute this instruction, I want to loop back to here, okay? Sometimes I'm going to loop. So this is like something like infinite loop. All the time you come here, you come loop back. Sometimes I want to repeat this part 50 times, like for. Remember for loop? So sometimes, so it's not, if you have a program for any programming language, usually we don't go this way. Sometimes you need, there are some sections I want to repeat this part of the code 50 times, 100 times. That's what I mean by loop. Okay, as I'm going to explain in this section, we have two types of loops. You have infinite loop. Infinite means you are gonna for all the time you're gonna loop back all the time. And you will see some programs. How can we do that? Also, you can loop for a certain number of iterations, like for loop. So you have some code. I want to repeat this code 100 times or 20 times, 30 times, okay, like for. So I'm gonna, that's what I mean by loop, okay? So that's what I'm gonna explain loop. The other one, we call it branch. So what do you mean by branch? You can look at the English name, branch. You have a branch. You can go this way or this way, branch, okay? Something like that, we call it branch. For example, I'm gonna come this way. These are instructions. We are gonna come this way. And then I have a condition here. If A is greater than 5, I have a condition. This condition can be true or can be false. So go to next. I want to do something like that. If A, this is not assembly. This is not even C. I'm just explaining. We want to do something like that. How? That's what I'm going to explain in this section. If we have a condition, if A is greater than 5, go to next. That means when I come here, I'm going to create a branch. When I come here, it's a branch. Either if the condition is true, next time I'm gonna execute this instruction. I'm not gonna execute this instruction, but I'm gonna come to here. So I'm gonna start executing instruction from here if this condition is true. If the condition is false, so here I have a condition, guys. If the condition is true, so the branch will be taken. The branch is taken if the condition is true. If the condition is false, the branch is not taken. What you mean by the branch is not taken? That means I'm gonna come this way. You got what I'm saying? Is that okay? So that's what I mean by branch. So I have a condition. This condition can be true or false. If it's true, so I'm gonna come to here, right? If it's false, so I'm gonna go this way. I have to branch. Is that true? Okay, guys. So I have a condition. If the condition is true, I'm gonna skip this part. I'm gonna come to here. If it is false, I'm gonna come here this way. Okay, guys. So anyway, I'm just here. I'm making definition. I'm just making here definition. I want you to understand when I say branch, you understand what I mean by branch. When I say loop means you repeat. You can't even tell from the English name loop. You repeat part, right? Branch means you can go this way or you can go this way. Okay. So now I'm going to explain how can we do that in assembly. But before I do that, I make like a classification. So we have branch instruction. We have 3 types of branch instructions. So you have an instruction to do branching. So to do a branch like this one, we have instructions. That's true. But I'm going to classify this instruction. So the branch instruction, they can be conditional or unconditional. Okay. They can be long or short. They can be signed or unsigned. Okay, guys. So these are the instructions we have. So the instruction I'm going to teach, I classify them to conditional, unconditional, long, short, signed or unsigned. So let me first define what you mean by conditional, what you mean by unconditional, what you mean by long, what you mean by short. For sure, you know what I mean by signed or unsigned, but I'm going to explain it. So let's talk about what do you mean by when you say this instruction is conditional or unconditional. You can even tell from the English name. Conditional means there is a condition. If the condition is true, the branch is taken. If it is not true, the branch is not taken. You can tell from the English name, this is unconditional branch. So there is no condition. All the time we are going to branch, all the time. You got what I'm saying? So let's see how we can do that. For example, I give you an example here. If I want to do something like that in programming, and in any programming language, usually we do something like that. I come here, and then I have a condition. If A is greater than 2, there is a condition. And then if this condition is true, I'm going to come here. If it's not true, I'm going to come here. So this branch is going to be taken only if the condition is true. Otherwise, it's not going to be taken. That's why it's called conditional branch. Is that okay? So the condition is the branch is going to be taken only if it is true. However, we have another type of branch. We call it unconditional branch. You can tell from the English name. So there is no condition. All the time should be taken. For example, I'm going to put here I'm going to put here a unconditional branch. So every time I come here, look here, guys. Here I execute some instruction, and every time I'm going to come here, I'm going to skip this part. All the time, because it's unconditional branch. So all the time, once I come here, I have to skip this part. All the time I come here, I'm going to skip this part. When I explain this way, some students ask me, okay, so that means you have a part, and this part you always skip it. So what is the point? You put some code, and all the time you are going to skip this code. Okay, I'm going to tell you, I'm going to give you example to understand what it means. For example, guys, here, if A is greater than 2, I want to execute this part. However, if A is not greater than 2, I'm going to do this part. So if I already executed this part, I have to put one instruction here to skip this part, because already A is greater than 2. So I have to put something here to skip this one. So if you come here, you have to skip this one, because you should not do this one, because you already A is greater than 2, right? Makes sense? So unconditional here, we can use it like to achieve somehow with this one, as you will see later. Okay, I'm just giving you example here. If A is greater than 2, I'm going to execute this instruction. But if it is not greater, so I want to do this part. So I'm going to put conditional branch here. Okay, so if the condition is true, I'm going to come this way. Okay, and then I have to skip this part. Anyway, I'm going to clarify it later. But for now, I'm just making a definition. We have conditional and unconditional branches. Okay, guys, any questions? I'm gonna give you details later. I'm just in make definition. So later when I give you two instruction, I'm gonna tell you this conditional, you should understand what I mean. This unconditional, you should understand what I mean. Okay. Now, also we have what we call long and short. Long and short. So what is the meaning of long and short? I'm gonna tell you what it means. Okay, look here, guys. If I come this instruction, and then I'm gonna come to this instruction. This is BRA branch instruction. This instruction I'm gonna teach later. This construction, this one is unconditional instruction. Okay. So if I come this way, guys, and then I'm gonna branch to next. So I'm come here. Once I come here, this instruction is gonna be jump or branch. So I'm gonna come here. Unconditional. So that time I come here, I'm gonna come back to it. Okay. So this jump from here to here, is there a limit? How many bytes I can jump? Remember, the instructions we have here should be stored in memory in bytes. Okay. So what I mean here, guys, is, for example, if this instruction, just an example, it's at the memory location 700, for example, 730, for example. Okay. And this one at 700. Okay. So that means there are, from here to here, there are around 30 bytes. But this is for sure you need to transfer, you convert this. So 30 bytes from here to here. Okay. So my question is, or the question is, I'm here and then I want to jump to here. I'm here and then I want to jump to. Is there a limit? Can I jump if I'm here in the memory? Can I jump to anywhere, or there is a limit on where you can go? Yes, there is a limit in case of short branches. So we have two types of branches. One type is called short. In case of short branches, there is a limit. The limit is you should not jump more than 128 bytes if you go backward. If you go forward, so it should not be more than 127 bytes. Is that okay? So there is a limit. So that means if you put too much code here, that more than 127, this branch should not work. You have to use the long one, because the long one has no limit. So again, let me summarize it. We have two types of branches. One is long. In case of long, you can branch, there is no limit. You can jump to anywhere in the memory. However, for short branches, there is a limit. Limit means from here to the location you want to go, you want to go to. Okay. So the limit, it should not be more than 128 bytes backward or 127 bytes forward. Is that okay? You cannot jump more than that. By the way, the good thing here, if you make this mistake, Code Warrior is going to give you error. In this error, it's going to tell you something like out of range. I don't remember the exact sentence, but the sentence is gonna have something like out of range. This branch is out of range, something like that. Is that okay, guys? So again, I have two branches. One can branch anywhere in the memory, and the other one, it's short. It can be, there should be a limit, okay? You cannot branch, there should be a limit on the instruction you put here, okay? Or you put here. If you branch backward or you branch forward, there is a limit. Is that okay? So the thing is that here, guys, so when I teach every instruction I'm going to teach, I'm going to tell you this instruction, we have two versions. One version for long and one version for short, okay? So maybe I'm going to jump here to show something related to this one. So let me go here. Oh yeah, look here. Yeah, sorry. Yeah. Look, guys. This table, in this table, you can see all the branch instruction I'm gonna teach in this table. Okay, there are many, as you see here, branch instructions. Okay, if you see here, guys, you can see that every instruction you can see here, BCC. Don't worry, I'm gonna explain what this means. One without L and one with L. So you can see. Let me use red. So you can see here. Every instruction, and then for every instruction we have two versions. Every instruction, two versions, right? Every instruction we have two versions. Okay, one same thing here. Okay, one without starts with L, and the other one exactly same thing, but it does not start with letter L. Okay, so every instruction we have two versions. One starts with L and the other one without letter L. Okay, so what this means? It means the ones that start with letter L are long, and the ones that don't start with letter L are short. Is that okay, guys? So every instruction I'm going to teach, there are two versions, one with letter L and one without L. Okay. By common sense, someone can ask me, okay, you are telling us every instruction you are going to teach, there are two versions. One has a limit on where you can go, and the other one doesn't have a limit. So it's easy. All the time, I'm going to use the long instructions. You got what I'm saying? So why I would bother myself and I use the short instructions, right? So I can use the long instruction all the time. My answer is yes. You can just go for the long instruction all the time, just for peace of mind. Okay. So, but again, I want to tell you why I am teaching the short instruction. If this is the case, I can use long all the time. The reason is, if you care about efficiency, the problem is, I'm going to explain it to you. The long instruction usually takes more space in memory. When you convert this instruction to machine code, it takes bigger space. And usually they take more time than the short instruction. So the short instructions are more efficient than the long instruction. So if you care about efficiency, yes, you can, in this case, short are better than long. But I think for this course, you can just use long all the time. Is that okay? So you know why? Long takes more time? I'm going to tell you why. Because this instruction here, when it converted to machine code, in memory, it needs 2 bytes for the address, for the target address. So here it's going to be a part of the. So if you look at the machine code of this instruction, you will find the target address where you want to go. So it's going to take 2 bytes in the memory, right? So the target address should be a part of the machine code. So that's why you need 2 bytes for the target address. I think you need 1 or maybe 2 bytes for the instruction itself. Okay. However, for short, I need only 1 byte, not 2. Why 1? This is address. Yes, but in case of short, I can go back 128. Sorry, my negative, or I can go positive 127, because what I do, I get the current address, and then I can add the shift So this is like a shift. I'm going to shift back or shift here, right? And as I explained before, these two numbers are enough to store them in a byte. So again, if you don't understand it, that's okay. But I'm explaining what happens. In case of long, you have to put the address. But in case of short, you have to put the shift. So I'm here. Should I add how much bytes shift? So I'm gonna use this address, and then I'm gonna decrement some bytes or increment. Okay. And this shift should be a byte. That's why I'm using 128 positive, because this is the range of a byte, right? That's why this one is more efficient, okay? Because I don't need to store the whole address, just one byte. Anyway, so conclusion. We have every instruction I'm going to teach. We have two types of instruction. One is called short, one is long. For peace of mind, you can use long all the time. I'm totally fine with that. But also, you should understand, usually short is more efficient than long. Maybe I don't care much in this course about efficiency. Maybe in the future, you need something like that. If you care too much about memory space, if you care too much about how much time, execution time, and so on. But okay. Also, there is another reason why I'm explaining long and short, because we have a very few instruction I'm going to teach later, maybe 2 or 3 instructions, the only short. We don't have the long version of them, right? So all this instruction, long and short. But later, I'm going to explain just maybe 2 or 3 instructions, a few instructions, they are short, only short. They cannot be long. Is that okay, clear, guys? Okay. Now, let me go back what I'm doing here. What I'm doing, guys, here, I'm explaining for branch instructions. Here I'm making classification for the branch instruction. I told you the branch instruction, I'm going to explain they can be conditional or unconditional. Okay, I explain what I mean by conditional, what I mean by unconditional. They can be long and short. I explained what I mean by long and short, and I explain the whole story. The last thing here, signed or unsigned, right? Signed or unsigned. So we have some branches for signed, we have some branches for unsigned numbers. Okay, you told us, okay, so stop here. Okay, I'm gonna stop here. Look here, guys. So you told us, before I explained some instruction, I didn't tell you for signed or unsigned because it can be used for both. It doesn't matter. Like data transfer instruction, addition, subtraction. In these cases, it doesn't matter. Okay, if it's signed or unsigned, it's exactly the same thing. Okay, and then when you explained multiplication and division, this was the first time you tell us this instruction for signed and unsigned, because signed or unsigned, they are different. Multiplication for signed, different. That's why you have different instruction. Yes, that's true. Same thing here. When you have like a branch here, when you have a condition, it matters. I'm gonna explain to you now why it matters. For example, here, guys, I want to do something like that. If A is greater than 2, go to next. I want to do something like that. Okay, guys. So let's have an example. I just want to tell you, I want to convince you why signed or unsigned matter here. Why they matter? Okay. So look here. For example, register A is storing this number. Okay. I want to do a comparison like this one, and I want to branch if this condition is true, right? So try to look here. If this number is signed, that means A is my -1, and -1 is not greater than 2. That means this condition is false. That means the branch should not be taken. Okay. However, if this number is unsigned, this number becomes 255. So 255 is greater than 2. Yes, the condition is true, and the branch has to be taken. You understand what I'm saying? That is why I cannot do it in one instruction. Okay, so there should be 2 different instructions, and then you are a programmer. When you write your program, you know if your number is signed or unsigned, and then it's your responsibility to use the correct instruction. Is that okay, guys? You are convinced here why I need to do it? I need here separate instruction for signed or unsigned. Okay, now I'm gonna give you the details. All what I did right now, I'm going to start giving you the details, but all what I did, I just made classification. I'm expecting now, after what I explained, I'm expecting that you understand when I teach instruction and I tell you this instruction is conditional, you understand what I mean. When I tell you this one is unconditional, you understand what I mean. When I see this one is long, this one is short, this one's signed for signed number, this one for unsigned number. You understand? If you want me to repeat any part here, if it's not clear, this is a problem, guys. I explained something right now. Okay, I assume you understand it. Okay, so later I'm not gonna explain it again. I assume you know it. Okay, if you don't understand it now and I just use it later, there will be a gap between us. We're gonna speak different languages. Okay, I'm saying something and you don't know what I'm talking about. Okay, because it's like a chain, Okay, so a ring was missing, is missing. Anyway, so is that clear now? You understand? So later I'm gonna say this instruction for signed or for unsigned or for long or short or conditional or unconditional. Any question? Okay, so now I'm gonna start give you the details. Number one, I'm gonna start teaching instruction. I didn't teach instruction yet. I'm branch instructions. I just made a classification. Now let's talk about unconditional instructions. Okay, again I said unconditional means there is no condition. The branch will be taken all the time, and sometimes you will need to do something like that. I'm gonna explain later why sometimes every time I come to this point, I have to jump to here all the time. There's no condition. Yes, it's gonna be clarified later, but anyway. So for unconditional instruction, we have only one instruction for unconditional, only one, which is BRA, branch. And then next to branch, you have to put a label, name, where you want to go. So you have to put a name, right? So that's it. So we have two versions of this instruction, BRA and LBRA. Okay, so one without L and one with L. So L here means long. So this short, this long, right? So for example, here this is an example for infinite loop. For example, every time I come here, I'm going to say branch BRA, branch to next. And here I have to label this line. So every time I come here, this one is going to come here. Come here. All the time, this branch will be taken all the time. In chapter 3, we are going to do something like that. We are going to do in chapter 3, one of the program, we are going to do like a flashing LED. Okay, I don't have it, the board now. So on the board, we have an LED. This LED, we are going to do flashing. So I want to turn it on for 1 second, off for 1 second, on for 1 second, off for 1 second. How we are going to do something like that? So I'm going to turn the LED on. I'm going to write an instruction to turn the LED on. And then I'm going to wait 1 second. Then I'm going to write an instruction to turn the LED off. Then I'm going to wait 1 second. Then I'm going to go back to repeat again. So it's going to be continuously. Okay. So how I can go back? For sure, I'm going to teach these instructions later, but how I can go back, this is unconditional instruction. Okay, guys? Very easy. So you should understand what I mean by unconditional instruction. You should understand how can we use it, like BRA, and then you can put name. Don't be confused. Next is not an instruction, guys. The word next, the word to begin here. These are names. It can be your names. Sometimes students are confused. You can say you don't know if this is a label or instruction. No, this is just a name. It can be any name, right? So here begin or next or whatever you call it. When most of the time I use one word like next. Something think it's an instruction. No, it's just a name. Yes.
You have to have the colon after next always. For the word after the word, you have to have the colon, or you just put the word. That's it.
Yeah, I think you don't need here. Okay, I think the coder can accept it without colon. I think. Okay, you can try it, but I think yes, answer is yes. It's gonna accept it without colon. But the most important thing, you should not leave a space here. So this one has to start from the very beginning, Okay. Okay, guys. Now, so I'm done with unconditional. Very easy. I'm done with unconditional instruction. Now I'm gonna move to conditional instruction. We agreed for conditional, there should be a condition, and then you are gonna branch. Or you are going to branch. Oops. Hello? Yeah. So we're going to branch if the condition is true or if the condition is false. So now, how I make conditions? I think I explained it before, but I'm going to repeat it here. How can we make conditions here? How it works? I'm going to tell you how it works. Let me make a slide here and then. I want to do something like that, guys. For example, I want to do if A for example, is equal to 5, go to next. Is that okay? I want to do something like that. So I need to check the condition, this condition. Okay. How can we do something like that in assembly? How the hardware can figure out if this condition is true or not? Okay. The way we do it, guys, as I explained before, if you remember, number one, this if you want to do this part, it has to be done in 2 instructions, not one. So if I want to do something like if statement, I have to use 2 instructions. One instruction has to do subtraction. Yes, subtraction. The other one should use conditional branch. Yes. So if I want to do something like that, guys, I have to use 2 instructions. One should do subtraction, the other one should do conditional branch. So subtraction, why you are going to do subtraction? I'm going to tell you. So here, what I have to do here, I'm going to subtract. I have to compare A to 5 or 5 to A. Okay, so I need to compare them. So the way I do comparison this way, I'm going to do subtraction. So I'm going to subtract 5 from A. Is that okay? So why you do subtraction? Are you interested in the difference between A and 5? Are you interested in the difference? No, I don't care about the difference. I care about the flags, right? Because when I do subtraction, after you do subtraction, flags are updated. Right? So here we have several flags. 0 flag, we have carry flag, V flag, and we have negative flag, right? So we have these 4 flags we use. Here in equal, I only care about the 0 flag. I don't care about the other flags. You got what I'm saying? If it is greater, if it is less, these ones are going to look at other flags. But now let's take this case. For equal, I care about the 0 flag. So what I'm going to do, number one, I'm going to do subtraction. And then this branch instruction is going to just look at the 0 flag. If the 0 flag is 1, that means A is equal to 5. That means the branch should be taken. So I'm going to branch, right? Otherwise, I'm not going to branch. Again, very simple. So here, guys, in order to do a conditional branch, the way we do it in assembly, you have to use 2 instructions. One instruction, you have to do subtraction, right? To update the flags. The second one is going to check, just to check the flags. And then based on the value of the flags, it's going to jump or not. I give you one example here. In case of equal, okay, I just care about this instruction is going to look at the 0 flag. If the 0 flag is 1, it's going to branch. Otherwise, it's not going to branch. Same thing for greater, for less, it's going to look at different flags here to know. So now you should understand why we did subtraction here. I just did subtraction so that I can update the flags. Why? Because my next instruction is going to look at this. It's going to look at these flags. It's going to check these flags, right? So here, this instruction should update the flags so that this branch can work. That's why usually you are going to use 2 instructions together. One subtraction and the other one is condition. Is that okay, guys? Any questions? Okay. So let me just make here. So now you understand we need to do subtraction in order to update the flags, and then I'm going to use jump instruction. Jump instruction is going to just check the flags, and based on the value of the flags, they are going to jump or not. Very easy, right? So now, but there is a problem here, very, very small problem, not just very small problem. Look here, guys. If I use subtraction, if I use normal subtraction or the normal subtraction, guys. So what's going to happen? A is going to equal to A take away 2 or minus 2. Okay. So that means I'm gonna update A. I'm gonna change A. I'm interested in the difference, so I'm gonna use this difference somewhere. So the difference is gonna be stored in A. Are you interested in this difference? You're gonna use it later? No, I'm not interested in the difference. I'm just doing subtraction because I want to update the flags. I don't care about the difference. So why you change A? Maybe I want to use A later in my program. Maybe I want to use A later. You destroyed A, okay? Because I'm going to use it later in my program. I'm not interested in subtraction. That is why they made a new instruction. We call it compare instruction. Compare instruction is exactly similar to subtraction, but the result is not stored anywhere, right? So here, this one is doing subtraction. Yes. This one also is doing subtraction. This one updates flags. This one also updates flags. This one stores the result in A. This one does not store the result. You know what I'm saying? Because I want to compare. So I want to do subtraction, but I don't want to change A because I need it later. Is that okay, guys? That's why they invented a new instruction. We call it compare. So compare is similar to subtraction, but the result is not going to be stored because actually I did subtraction just to update the flags, so that the next instruction, which usually this is how it works: compare, jump, compare, jump, compare, jump. This is how it is. You have to put compare to update the flags, and then you have to use one of the jump instructions that's gonna jump based on the value of the flags. Is that okay? So here, what I'm gonna teach right now, you should understand the difference between. So let me tell you the conclusion now. So conclusion now, guys. Here, if you want to do conditional branch, number one, you need to subtract in order to update the flags. This number one. Okay. Number two, you have to use branch instruction because this branch instruction is going to look at some flags and it's going to branch or not. It's going to make a decision either branch or not. I give you one example. In case of equal, I only care about one flag, zero flag. Is that okay? So I'm not interested in to store the difference in A. That's why we are going to use compare. That's number one. Number two, keep in mind, I'm doing subtraction. Very tricky. I'm doing subtraction because I update the flags, right? If the flags, in very rare cases, if the flags are already updated, I don't need subtraction. I don't need to subtraction. You can just use branch. It's going to happen in some cases in this course. But honestly, most of the time, we're going to do compare because you have to update the flags anyway. If the flag is already updated, so if you want to do compare, that's okay, but you don't need it, right? For example, if you use load, if you load A, for example, with some value, this load instruction is going to update the zero flag anyway. It's going to update the zero flag. So you can, after that, you can just use branch. You don't need to compare because this one, if what you are loading here, if it is zero, so that means already the zero flag should be 1, right? So you don't need to compare. If you want to, again, I don't know, this is somehow tricky, but again, if you want to use compare, that's okay. You can use it, but it's like redundant instruction. You don't need it, right? But you should understand, I'm doing compare to update the flags. If the flags are already updated for some reason, so I don't need it, right? But again, if you want to put compare, it's not wrong, okay? Just to be in the safe side, that's okay. So I'm going to explain now what, any question you understand now? You understand? Number one, how can we do comparison like this one? Okay, subtraction, and then use one of the branch instruction. Okay, and then I'm going to explain now. You should also understand what is the difference between compare and subtraction. They're almost the same, right? The only difference, this compare does not change any registers because the result is not stored anywhere. This compare instruction only change the flags, update the flags, okay? But it's not going to update any registers because the results are not stored anywhere. So let's see what instructions we have here for compare instruction. Number one, we have CBA, compare B to A. So this one is going to subtract B from A, right? We have compare A to a memory location or immediate value. For memory, again, you can use any format for memory. I explained different formats for memory. You can use any one of them, okay? So this one is going to actually subtract the immediate value or memory location from A, as you see here. We compare B. This one also is going to subtract the immediate value from B. We have compare D, register D. Okay, so this is three instruction for bytes. The coming instructions here are for words, right? So here I'm gonna subtract immediate value or memory location from D. Same thing here for X, for Y, and for stack pointer, as I'm gonna explain later. Okay, guys, is that clear? Okay, let's have an example. I like examples. Okay, so for example, I want to do some, let's do this example here, exactly same thing. I want to compare E to 2. I want to do condition like this one. You know how I can do this condition? Using these two instructions. So the first instruction here, I'm going to compare A to number 2. I'm going to compare A to number 2 in order to subtract. So this instruction is going to subtract 2 from A, is going to update the flags, and A is not changing. It's not going to store the result anywhere, right? Just I want to update the flags. And then after this instruction, I'm going to use branch if equal. This is one of the branch instruction I'm going to teach right now. It's called this one, B for branch, EQ for equal. So this one is going to branch if equal. If A is equal to 2, it should branch. How this one works, this one should branch. This one is going to look at the 0 flag. If the 0 flag is 1, it's going to branch, right? Otherwise, it's not going to branch. So they should be coupled. These two instructions should be coupled together, right? One to update the flags. The other one is going to look at the flags and then it jump if the flag is 1 or not. So this instruction is going to just look at the 0 flag. If it is 1, it's going to jump. If otherwise, it's not going to jump. Okay. So that's why, by the way, guys, sometimes we call this flag 0 flag, or sometimes we call it equal flag. Sometimes some people call it equal flag or 0 flag because they are the same thing. 0 or equal is the same thing. You know, we should understand how equal and 0 are the same thing. Okay. Any questions? Okay, guys, any questions? Okay. So now, what I'm going to do now, in addition to compare, we have also some instruction, we call them test instruction. Test instructions. Okay. So what is this instruction? They are similar compare. Yes, they are similar compare, but always they compare to 0, right? So if, for example, if you want to compare to 0, for example, here, if I want to compare E to 0, you can do this way. You can say compare E to 0, right? Or you can use test instruction, because test instruction are only comparing to 0 only. But this one is general, can compare to any number, right? So that's what I'm gonna here. So test instruction, we have only 3 instructions here for test instruction. They are similar, same as compare, but it compares to 0, right? So you can say test A. That's it, test A, that's it. So this one is going to actually subtract 0 from A. So this one you can use compare to 0, same thing. However, this one may take more space, less if this one it may be more efficient, but they can do the same thing, okay? Same thing here, we have here test B. So we have only 3 instructions, test A, test B, and test, and then you put here memory location for byte. This one is interesting. I'm going to tell you why this one is interesting. Here, test B. So this one is going to subtract 0 from B. So this is similar to compare B to 0, right? You compare to 0. Okay. So test, and then you put here a memory location. So this one is somehow interesting because if I say test 1000, you know what this means? It means I want to compare memory location 1000 and 0, compare it to 0, right? This way, using one instruction. However, if you want to use compare, because if you go back to compare, always compare here, it has to, you compare a register to memory location, right? I cannot, there is no instruction here to compare a memory location to 0 or any immediate value. That's why if I want to do the same thing using compare, so number 1, I have to use 2 instructions instead of 1. So I can use load A 1000 and then compare E to 0. Two instructions. Maybe this one is interesting because if you do it using compare, you are going to write 2 instructions. But if you do it using test, it's going to be only 1 instruction. But again, I don't care in this course when I grade. I don't care about for sure. In the beginning, it should be okay. If you are not efficient, if you write too many instructions, you should in the beginning you should care about it. getting the program working in the beginning. But gradually, you want to be professional. To be professional, that means you can do the same thing, but using like a small number in instruction. Okay. So in the beginning, yes, you can. I'm totally in grading. I don't care as long as the program is working. I'm totally fine, right? I'm not gonna count how many lines of code you are writing. Okay. So if there are some redundancies there, I don't care as long as it works. It should be okay to me. Okay? But you should, for example, here instead of writing 2 instructions, you can just do it using 1 instruction. Okay, guys, any questions? Okay. So now conclusion. For conditional instructions, number 1, you have to do compare or test the instruction, and then you have to use one of the branch instructions. Okay. So we have here a number of branch instructions. Still have 1 minute. Okay. So we have here a branch instructions. So here, this branch, as I said here, this is how we do condition, guys. Number 1, use compare. Number 2, you have to use one of the instructions we have. Here I give you only one instruction for equal, but actually it may not be equal. It may be greater. It may be greater or equal. It may be less or equal, right? Also, it can be signed or unsigned, right? So that is why this is the branch instructions we have. So again, to be on the same page, what I'm explaining right now, the branch instructions, these are the instructions. Here, you have to use after compare, right? This one's the one you have to use after compare. Okay, so I'm going to teach you this instruction next time. Any questions, guys? Okay, again, guys, please, this topic is very important. I consider it's like one of the most difficult parts in the course. Or it's not difficult, but students may find some difficulty in this part. Also in the addressing modes. Okay, so try to read this slide. If you have any question, you can ask me.